Alright, so this LeetCode question is called min stack. It says design a stack that supports push, pop, top, and retrieving the minimum element in constant time. So the methods they want us to create are push, which adds an element to the top of the stack, pop, which removes the element from the top of the stack, top, which gets you the top element, and get min, which gives you the minimum element in the stack. So the example they use is this. They instantiate a new stack, and then they push the numbers -2, 0, and -3. When we call get min on that, it returns -3 because -3 is the smallest number of those three. Then when you call pop, it's going to pop off the last element that was added, which is -3. And then when you call top, it returns 0 because that is the second to last element that was added. But now when you call get min, it returns -2 because of 0 and -2, -2 is the smallest number. So let's just look over here real quick. LeetCode has a method called min stack. This is going to be used as the constructor, and then it wants us to implement push, pop, top, and get min, as we said before. And then it has an example of how exactly these methods will be called. All right, so before we start, let's just go over what a stack is. A stack is just a data structure in which the last element added will be the first one to be removed. So let's say we have the number 1 followed by the number 3 followed by the number 0. If we want to remove the element, it's always removed from the top, so the number 0 will be gone. Say we add 7, 10, what's going to be removed? Whatever is at the top, so the number 10 is gone. This video isn't about how to implement a stack, but I do also have a video for that, which I've linked down below. All right, stacks don't actually have a way to get the minimum element, so the way to solve this problem is by using two different stacks. So let's say this is the regular stack, and this is the min stack. The min stack will keep track of the minimum element. It's always going to be at the top of this stack. So let's talk about adding an element. Whenever you add an element, you always add it to the regular stack, let's say the number 5, and then what you do is you check to see if the min stack is empty. Yes, it is, so you add it to the min stack. What you also do is if it's not empty, you check to see if the element in the regular stack is smaller than the element in the min stack, and if it is, you add it there. So let's do that example. Let's add the number 1. Is it smaller than the element at the top of the min stack? Yes, so you add it there. Let's do the number 7. Is this smaller than the top of the min stack? Is this smaller than the number at the top of the min stack? No, it's not, so you don't add it there. And let's do the number 0. Is this smaller than the number at the top of the min stack? Yes, it is, so you add it there. Notice that at the top of the min stack is always the smallest number. All right, so let's talk about removing elements. Anytime we remove an element, we always remove it from the top of the regular stack. But then what we have to do is we have to check to see if that's the same element at the top of the min stack. If it is, we also remove it from there. Let's do a couple more of those. So we remove an element, bring it over here. Is that the same element as the element at the top of the min stack? No, it's not. So all we have to remove is this one. Let's do one more. Pop the element at the top of the stack. Is this the same element at the top of the min stack? Yes, it is. So you remove it. All right, let's just do a quick example with both removing and adding. So let's say we add the number 0. Is this smaller than the element at the top of the min stack? Yes, add it there. Let's say the number 8. Is this smaller than the number at the top of the min stack? No, it's not, so we don't add it to the min stack. Let's do a couple removes. Take the number 8 off. Is this the same number at the top of the min stack? Nope, so you just remove it. And then the number 0, let's pop that off. Is this the same number as the number at the top of the min stack? Yes, it is, so you just remove both. All right, before we start implementing this, I have to mention that JavaScript doesn't have a native stack data structure. So what I've done is implemented my own at the bottom. I'm not going to go over the actual implementation of this in this video. Just know that I have another video that I've linked down below that has this. And also I have a link down below which includes all of the code for this video. All right, finally, time to start implementing this. Remember, the first thing we have to do is create two stacks. So we'll say this dot stack equals a new stack. This will be the regular stack. And then we have this dot min stack also equals a new stack. And that'll look like this. This would be the regular stack, and this would be the min stack. All right, so let's move on to the push method. Remember that anytime we push something, it always gets pushed to the regular stack. So this dot stack dot push x. Okay, so let's pretend that's the number 1. We're not done with this. Remember that we also need to sometimes push things to the min stack. And what are the two conditions for that? Well, if the min stack is empty, so min stack dot size equals 0, then we add it to the min stack. What's the other condition? If the element that we're pushing to the regular stack is smaller than the top of the min stack. So else, if x is less than or equal to this dot min stack dot peak, we need to add it to the min stack. And that would look like this. So right now we just added the number 1 to the top of the min stack. Is the number 1 smaller than the top of the min stack? No, but the min stack is empty. So then we definitely have to add the number 1. Next, let's implement the pop method. Remember, the pop method just removes the element at the top of the stack. So we'll say let, and we'll call it removed element. So let removed element equals this dot stack dot pop. So remember that no matter what, anytime we pop it off the regular stack. So that'll look like this. Okay, so what's the condition to also remove it off the min stack? That condition would be if the removed element is the same as the element at the top of the min stack. So if it equals this dot min stack dot peak, then we also remove it off the top of the min stack. And that would look like this. The element we removed in the regular stack is the number 1. Does that equal the element at the top of the min stack? Yes, because that's also the number 1. So we remove it. Next, we'll implement the top method. So let's just add some things to our drawing real quick, just so that it makes sense. We'll add the number 1, which will go here, the number 2, which would not go there, and then the number 0, which would go here also. Top is just what's at the top of the regular stack. So we return this dot stack dot peak. That would be right here. And now we go to the getMin function. GetMin just returns what's at the top of the min stack, because remember that's always the smallest element. So we'll just return this dot min stack dot peak. All right, and that should be it. Let's run the code. Looks good. Let's submit it. All right, so our solution was better than about 84% of other JavaScript submissions. As usual, the code and written explanation are linked down below. See you next time.